Logicians, you are halfway through the class at this point. We've made it through chapter 1 and chapter 6, and we're moving on to chapter 7 today. If you're watching this in spring of 2020, I hope you all are staying safe. If you're watching this in the future, then I hope everything's going okay for you. Yeah, I'm just going to jump into the content. I'm not sure what else to say about that. So, chapter 7 is about natural deduction. I'm going to read the intro to the chapter. You'll see that we're building on a lot of the things that we learned in chapter 6, but we'll be going about proving that valid arguments are valid in a different way. And that's using rules of inference. So let's talk, let me read the opening of the chapter, and then we'll get into the skills that you need. So natural deduction is a method for deriving the conclusion of valid arguments expressed in the symbolism of propositional logic. The method consists in using sets of rules of inference, which are themselves valid argument forms. You'll actually find the first 4 that we'll be looking at for this lecture down in the bottom right of the screen. So using the rules of inference to derive either a conclusion directly or a series of intermediate conclusions that links the premises of an argument with the stated conclusion. Natural deduction gets its name from the fact that it resembles the ordinary step-by-step reasoning process people use in daily life. It also resembles the method used in geometry to derive theorems relating to lines and figures. But whereas each step in a geometrical proof depends on some mathematical principle, each step in a logical proof depends on a rule of inference, so a valid argument. Natural deduction is similar in some respects to the truth table method, but truth tables can help us determine if an argument is valid or invalid. Natural deduction is just for demonstrating that valid arguments are in fact valid. So it's of no help with invalid arguments. But it's useful because it shows in a sort of everyday sort of reasoning, something resembling everyday reasoning, that a valid argument is indeed valid. So with that being said, let's jump into the rules here. So, and we should be familiar with some of these rules from way back in chapter 1. So the first rule that we're given is called modus ponens, but you just know it as MP. So MP is the first rule. MP tells us that if you have a conditional statement, for example, P horseshoe Q, and if you know that that's true, and if you know that P is also true, so you know that everything before the horseshoe is true, then you also know that Q has to be true as well. So if you know if P then Q, and if you know P, then given that first line, if P then Q, then you know that Q has to follow. As a callback to the last chapter, we can see this rule. So look over here on the right-hand side. Here we have P horseshoe Q, and we're going with this symbol, this, I guess I'll do it this way, this symbol for horseshoe now because that's easier to find on the keyboard. So that's a symbol for implication, for if-then statements, for horseshoe. So here we have P horseshoe Q, and if we were given that P horseshoe Q was true, and if we knew that P was true, then we would also know that Q would have to be true, because if Q was false, then we would say P was true, the antecedent was true, and the consequent was false, with the horseshoe being true. That should hurt your brain at this point. If you know that the horseshoe is true, then it can't be P being true and Q being false. It would have to be any other combination of truth values. And if you know that P is true, then Q would also have to be true. So we would just fill that in as true. And that's MP. Now, it's important to recognize that P here is just, note this lowercase letter, it's just a variable that stands in for everything that comes before the horseshoe. And Q is just a variable here that stands in for everything that comes after the horseshoe. So we're going to look at some instances of the rule below. So look at the first one over here. Here we have A horseshoe, parenthesis C wedge B, close parenthesis. And then on the second line we have A. So what can we derive from that using MP? Well, note on the model here we have P horseshoe Q and P. And here we have A horseshoe C wedge B and A. So on the second line we have A, which is everything that comes before the horseshoe here. So MP tells us what we can get is everything that comes after the horseshoe. Because again, P in our model is just everything that comes before, and Q is just everything that comes after. So what this instance is telling us is if A, then C or B. A, so we can derive C or B from that. Let's look at the second example. So the line here, the minus sign, will be our new symbol for the tilde because it's easier to find than the tilde. I guess the tilde is right there, but we'll be using the minus sign. So here we have if tilde B, then C. And then on the second line, again, we have everything that's before the horseshoe. So we can derive from that what we know now is C. Because we know if not B, then C, and not B. So now we can know C with this rule. A final instance of this, one thing to note is the lines. So up here we have P horseshoe Q, and then we have P, and then we derive Q. These lines could be switched. It doesn't matter. Everything above the line is what we're given, and below the line is what we're deriving, what we're now knowing as true. With this chapter, it becomes really clear what we're ultimately trying to do in logic, which is preserve truth. So if we know the things above the line are true, we can very safely say that the thing below the line is true because we're using a valid argument to derive it. So if these lines were switched, if the P was first and then we had P horseshoe Q on the second line, we could still get Q just as easily because we would still have, we'd know that P was true and we'd know that if P then Q was true, so then we could derive Q. So take a look at this example then. Here we're given on the first line a tilde, open parenthesis X, and now we'll be using the equal sign to stand in for the triple bar. So X if and only if C, close parenthesis. On the second line, we're given tilde, open parenthesis, X, triple bar, C. And then horseshoe, tilde, Z. So on the second line, we have a conditional statement. On the first line, we have everything that comes before the horseshoe, or if you recall, the antecedent. And if we're given the antecedent as true, then we know that the consequent has to be true if we're given that the conditional statement is true. So we have on the second line, we have a conditional statement, a horseshoe as the main operator. On the first line, we're given everything that comes before that horseshoe. So now we can derive everything that comes after the horseshoe. So we can derive tilde Z. So note the P here is tilde X triple bar C. And the Q here is tilde Z, again demonstrating that P and Q can be very complex, but as long as the main operator is a horseshoe, and on another line we're given the antecedent as also being true, then we can derive the consequent. All right, so that's MP, and you'll see that down here in the box to the right. The second rule that we're given is modus tollens, and that's MT, and you'll just know it as MT. MT tells us, again, if we're given a conditional statement, so P horseshoe Q, and if we're given that the consequent is false, so tilde Q, then we can derive that the antecedent must also be false, so tilde P. To put that in more regular language, if we know that if P then Q, and we know not Q, then we also know not P. recall that when we were talking about consequence, we talked about the consequent as being a necessary condition for the antecedent being true. So if the consequent is false, then the antecedent also has to be false, because the consequent being true is necessary for the antecedent being true. So if the consequent is not true, then the antecedent cannot be true as well. Now, going back to the last chapter, this will look familiar. So if we're given that the horseshoe P, horseshoe Q is true, and we're given that the consequent is false, then what can we determine about the antecedent? Well, if the antecedent were true, then we'd have true, horseshoe, false, with the horseshoe being true, and at this point that should hurt your brain. So we can know that the antecedent is false. And false, horseshoe, false, if you look at the truth table for a horseshoe, is true. All right, so again, let's look at some applications of this rule. Well, before we look at applications, note, up in the top left here again, if we're given P horseshoe Q, and then on another line, if we have just one additional tilde, one tilde added to the consequent, then what we end up with is one tilde added to the antecedent. That will help clear up some confusion with this. So now let's look at the instances of the rule being applied. So here we have A horseshoe C wedge B. On the second line, we have a negation of the consequent, where the consequent is C wedge B. So our rule tells us if we have a horseshoe as the main operator, which we do, and if we have the negation of the consequent, so here's the consequent, and here's the negation of it. The negation of something is just one tilde added to it. It's saying it's not the case. Then what we get is, our rule tells us, we get the antecedent with one additional tilde in front of it. So the antecedent here is A, so we'll get one additional tilde in front of that, not A. So in more common language, if we know if A, then C or B, and if we know neither C nor B, then we can know not A. Let's look at another example, because this rule will get a little tricky with tildes. You just have to keep in mind all the time that P and Q themselves can contain tildes. So P, in this case, is tilde B. And Q, the consequent, is just C. So our rule tells us if we if we know that the consequent is not the case, so tilde C, then we know that the antecedent is not the case. So we have to add one additional tilde to that antecedent. So our antecedent here is tilde B. So we're going to need one additional tilde. So it's not the case that not B. Now be very careful and precise here. Eventually we're going to have a rule that will let us strip two tildes away or add two tildes, because saying it's not the case that not B is the same thing as saying B. However, forget about that for right now. What we need to make a proper negation is one additional tilde. So here we have tilde B. The negation of that is adding one extra tilde to it. That shows us that tilde B is false. All right, so one more example. Just like with modus ponens and P, where the line order didn't matter as long as we were given a horseshoe, and in the case of the MP, the antecedent. Similarly, in the case of MT, if we're given a horseshoe and as the main operator, and we're given the negation of the consequent, then we can derive the negation of the antecedent, what comes before the horseshoe. So the negation of that is just one extra tilde in front of it. So the line order doesn't matter. It doesn't matter if we have the main operator horseshoe line first or second or as we'll see in the proofs, third or fourth or fifth, as long as somewhere we have a horseshoe of as the main operator, and as long as somewhere we have the negation of the consequent, then MT tells us we can get the negation of the antecedent. All right. The next rule, and the most difficult for me in this chapter, but the more practice you get with it, the easier it will become, is hypothetical syllogism, so HS for short. HS tells us, if you have two lines where the main operator is a horseshoe, and the consequent of one of them is the same as the antecedent of another, then you can lose those parts that are the same, carry down the rest, so we'll carry down P, and we'll carry down R. We would cross out, one way you can keep track of this is cross out the things that are the same, so cross out the Q's, carry down the rest, and we'll be left with if P then R. So that's a technical breakdown of how to construct this hypothetical syllogism. Let's put it in common language. If we know if P then Q, and if we know if Q then R, then what we set up is a sort of like chain reaction. So we have if P then Q, if Q then R, so we can cut out the middleman, the Q, and go straight from if P then R, because it's sort of like dominoes falling, right? Like if we know if P, if that domino falls, then the Q domino falls. And if we know that when the Q domino falls, the R domino falls, then we don't need to even, we can skip that middleman. We know that if P falls, then R will eventually fall, right? So that's what we're saying over here with the horseshoes. And over here, we're saying it in common language. All right, so let's see that rule applied. So here we're given a horseshoe as the main operator, and again we have a horseshoe as a main operator. And note that the consequent of one of the horseshoes is the same as the antecedent of another one of the horseshoes. So hypothetical syllogism tells us that we can cut out the middleman and go straight to A, if A then Z, because we're cutting out the C wedge B, and we're cutting out the C wedge B because those are just middlemen between A horseshoe Z. So far, so good. Now, let's see what can happen, because again, P, Q, and R in this case can have tildes, they can be long propositions. Let's see what happens with tildes here. So here, P is tilde B, and Q is C. On the second line, we have C repeated, so the antecedent of line 1 is the same, or sorry, the consequent of line 1 is the same as the antecedent of line 2. And then we have tilde Y, whoops, tilde Y here being our R. So what does our rule tells us? Our rule tells us if we have the consequent and the antecedent the same of two horseshoes, we can cut that out and go straight from tilde B to tilde Y, because we know if tilde B then C, and if the C falls then the tilde Y falls, so we can cut out the C and go straight to the tilde Y. So tilde B horseshoe, tilde Y. Now the reason this rule confuses me sometimes is because, again, the order doesn't actually matter. The order of the horseshoes doesn't matter. As long as on some line we have a consequent of a horseshoe and a consequent of a line where the main operator is a horseshoe and an antecedent of a line where the main operator of a horseshoe, as long as we have them being the same, then we can cut those out and carry down the rest. So look at this one. Here we have Y, if Y then D, and on the second line we have if O then Y. So note what the parts that are the same here. Here we have a consequent, y, the same as the antecedent, y. So our rule tells us we can cut those out. We can cut out the middlemen here and go straight from if O, then D. Because we know that if O, then Y is true, and we know that if Y, then D is true. So we can cut out that middleman, I guess it's this way, cut out that middleman, the Y, and go straight from if O, then D. Because we have the consequent being the same as the antecedent. So we can cut those two out, carry down the rest, carry down the if O, then D. All right, finally, one more rule. And that rule is disjunctive syllogism. So all the rules that we've dealt with so far are rules for when horseshoes are the main operator. Disjunctive syllogism is a rule where a wedge is the main operator. So let's see what disjunctive syllogism tells us. It's pretty straightforward. So it tells us if we know P or Q, so if we know one thing or something else is true, and if we know that P is not true, then we know that Q has to be true. So if we know that an either or statement is true, like if we know you're getting pie or cake, and if we know you're not getting pie, then we know, well, you have to be getting cake, right? Pretty straightforward. In more regular terms, if we know P or Q and we know not P, well, then we have to know that Q is true. And calling back to the last chapter, if we know that this wedge is true and we know that P is false, well, in order for a wedge to be true, one part of it has to be true. So if P is false, then in order to make that true, Q would have to be true, right? And that's exactly what this rule is saying. So one thing to note about this rule tells us only that if the first disjunct, so P, is false, then we can derive the second disjunct, Q. It does not tell us that if we know that the second disjunct, Q, so the part that comes after the wedge, is false, that we can get the first disjunct, P. Our rule doesn't tell us that. We're going to have another rule that will let us flip around wedges, but that's not for a few sections here. So follow the rule to the letter. If we know P or Q and we know not P, then we can get Q. All right, so let's take a look at some instances. So here we have A or, in parentheses, C or B. So the main operator here is this wedge right after the A. On line 2, we know A is not the case. So what has to be the case? Well, everything after that wedge. So C or B. Tildes, again, will make this a little bit complicated, but don't get too thrown off. Here we have the main operator as the wedge. So everything that comes before the wedge will count as our P. So here our P is tilde B. Everything that comes after the wedge will be our Q. So our Q here is C. So what will we need on the second line to derive C? What we'll need is a negation of the first disjunct. So here it's tilde B, so we need one additional tilde in front of whatever was our P. So our P was tilde B here. Remember, our P is just everything before the wedge. So we'll need that with one additional tilde in front of it on our second line. So not B. And that allows us to get what's after the wedge, C. One more application. Here we have, well, again, this is one that demonstrates the order of the lines doesn't matter. So down here, we have a wedge as the main operator. Here we have everything that comes before the wedge, so that will be our P. On another line, we need a negation of that. So here it is up here, tilde x triple bar C. And then we can get everything that comes after the wedge. So what comes after the wedge is tilde Z. All right, so those are 4 rules of inference. These are the steps that we'll be using in our proofs. Note, I have all those rules down here. So I have MP, HS, MT, and DS. So now let's take a look at the sort of problems that we'll be looking at for the homework and the test. So here are some practice problems. Our first practice problem gives us U horseshoe R on line 1, and on line 2 it gives us tilde R. So then the question is, what can we derive from this, and what rule are we using on what lines to get there? So our first line is if U then R, so we have a horseshoe as the main operator. So we're probably not going to be using disjunctive syllogism. We don't have any wedges here. So we're going to need a rule that has a horseshoe. So that leaves us with MP, MT, or HS. On our second line, we have tilde R, and R was our consequent. So on our second line, we have the denial, the negation of the consequent. So then we have to look at which rule gives us the negation of the consequent and what can we derive from that. We see MP doesn't use the negation of the consequent. On line 2, it gives us the antecedent. So that rule is not going to apply here. HS has 2 lines where the main operator is a horseshoe. That's not going to apply here. So what is MT? MT tells us if we have a horseshoe as the main operator, and if on another line we have the negation of a consequent, so here we do the negation of the consequent, we can derive the negation of the antecedent. So the antecedent here is U. So what can we get? We can get not U. So if we know if U, then R, and if we know tilde R, so not R, then we also know tilde U. And how did we derive that? The way we derived that was by, on lines 1 and 2, we use the rule MT. There we go, MT. All right, so this is a justification for the new step that we did. Here we were given 2 lines of information, 1 and 2. And then we derived this third line. We figured out what rule we could use on those first 2 lines, and the rule we decided was MT on those first 2 lines, and that would allow us to get tilde U. So note, the justification for the step is on the same line as the step we took. So we know tilde U. How do we know that? How do we justify that step? We show that we used Modus tollens on line 1 and 2. All right, so let's look at another practice problem. So here we have X. We're given that X is true, and we're given that if X, then I is true. So what can we derive? Well, here we have a horseshoe as our main operator. So it's not, again, it's not going to be DS, because DS, if we look down in the right here, has a wedge as its main operator. So it's going to be one of the other 3. So we're looking for a rule where we're giving a horseshoe and given the antecedent. So that's not going to be HS. HS has 2 horseshoes when we're given 2 horseshoes. MT denies the antecedent, denies the consequent. So the rule we're looking for is MP. MP tells us if we know P, if P then Q, and if we know P, then we can get Q. So here we know if X, then I, and we know X. So if we know X, and we know if X, then I, then we also know I. And how do we know that? We know that because we can do on line 1 and 2, MP. All right, so that's how we'll be taking these steps. So I'll do a few more, and then I'll let you get to your homework. So here we have two horseshoes that were given, H horseshoe J and G horseshoe H. And we're wondering what can we derive on line 3. So the rule that we have that allows us to use two horseshoes as the main operators is hypothetical syllogism. And recall again, that tells us if we have two horseshoes where the consequent of one is the same as the antecedent of another, we can cross out the rest and carry the rest down. So here we have two horseshoes, and here the antecedent is an H, and the consequent is an H. So what we know is if G then H, and we know if H then J. So we know if G is the case, then that works through H, and J is eventually the case. So we can cut out the middleman H and go straight to if G then J. And how did we do that? We did that by 1, 2, HS. You might be wondering why we're doing 1 and 2 when those are the only two lines that were given. You'll see shortly why we need to write the line numbers for justifications. So looking at another one here, we have Z wedge N and we're given tilde Z. So what can we get from that? Well, our rule disjunctive syllogism tells us that if we have a wedge, and if we have a negation of the first disjunct, then we can get the second one. So here we have either Z or N and tilde Z. So what can we get from that? We can get N. And how did we do that? 1, 2. Disjunctive syllogism. All right, so far so good. We've been given practice problems where we only have 2 lines, and we're asked, can we derive a third line? And we can with all of these so far. Now, in the next practice problem, down over here, we're given 3 lines, and we're asked, what can we derive from, what rule can we apply and derive something from those 3 lines? Now note, all the rules that we've covered work on only 2 lines. So we use 2 lines to derive a third line. Here we're given 3 lines. So what do we know? We know that 1 line will not be used here. So we need to figure out which of these 2 lines go together using a rule to derive the 4th line. So what do we have? We have N. We have N wedge J, and we have N horseshoe L. So the way we might go about this is by process of elimination. So can we use line 1 and 2 together? Well, line 2 is a disjunction. And the rule we have for disjunction is disjunctive syllogism. It tells us if we have a disjunction, an either or. And if we have not the first one, then we can derive the second one. But we don't have we don't have not N anywhere. So we can't do lines 1 and 2. How about lines 1 and 3? Well, that looks promising. Here we have if N then L, and here we have N. So we have the main operator as a horseshoe, and we have the antecedent on another line. And that looks exactly like MP down here. So down here we have if P then Q, P, therefore Q. So here we have a horseshoe as our main operator, P horseshoe Q and N horseshoe L, and we have our P, our N up there. So we can derive our Q, which in this case is L. And how did we do that? We did that on lines 1 and 3. M, P. Now, you can put 3-1 MP if you want, if it helps you keep things straight, but it doesn't matter. 1-3 MP or 3-1 MP, as long as you put the lines and the rule that was applied to those lines to give you this new line, then you're okay. All right, one more, and then I'll turn you loose on some homework. So here we have 3 lines again, so not T or B, and here we have not T. And then on line 3, if D, then T. So what can we get from that? What 2 lines work together? Again, we'll just do process of elimination here. These might start jumping out to you the more practice you get, but we'll go slow. So here we have not T or B. Can we use line 2? T2 gives us just not T. Well, maybe what we might suspect here is that we would be able to do disjunctive syllogism. But disjunctive syllogism tells us if we have P or Q, and if on another line we have not P, then we can get Q. Here we have not T or B. So what would we need on another line to get B by itself? We would need P, but with an additional tilde. So we would need not T with an additional tilde. So what we would need is not T on another line. And we don't have that. What we have is the first disjunct, but you can't, if you know that the first disjunct is true, you can't know that the second disjunct is true. So we can't do 1, 2 disjunctive syllogism. Can we do 1 and 3? Well, we have no rule that lets us use a wedge and a horseshoe when they're main operators, so 1 and 3 won't be the case. How about 2 and 3? Well, 2, we have not T, and here on line 3 we have if D, then T. So what rule can we use there? Well, on line 2 we have the negation of the consequent. Do we have any rule that allows us to use the negation of the consequent? We do, MT. So here with MT we have P horseshoe Q, and not Q, we can get not P. So we have D horseshoe T, or T is a necessary condition for D. We know that T is not the case, so we know that D is also not the case. And how did we get that? 1, nope, 2, 3, MT. All right, so what I just did are examples of exactly the sort of homework you will find in 7.1 Roman numeral 1. So there you're given there on my page 396, you're given 2 lines and it asks you, well, in the first few, you're given 2 lines that ask you what you can drive on a third line, or you're given even more lines and it asks you which 2 lines go together to get another line and what rules do you have to apply to get there. So using these problems as a model, go ahead and pause the video and do all the problems, so all 20 problems in 7.1 Roman numeral 1. And when you're done, unpause the video and we'll move on and I'll give you some examples of what you'll have to do in 7.1 Roman numeral 2. All right, so do all 20 problems, pause the video now. All right, so hopefully you did okay with those problems in 7.1 Roman numeral 1. If you have questions, these examples that I did are very much like the first 6 problems in that section. If you have problems with any of the other questions, go ahead and email me about which one you have a question on, and I'll respond with what the answer was and how you get it. All right, so now these practice problems are going to be more like the kind you'll see in 7.1 Roman numeral 2. So there, you'll be given a line and you'll be given a result. And what it's asking you is, how did you get to this result from this line? What did you need, in this case, on line number 2 to use together with line number 1 to get line number 3? And what rule did you use? So on line 1 we have W wedge H. Now this is a nice one to start with because we only have one rule that allows us to use wedges, and that's disjunctive syllogism. So disjunctive syllogism, if we look at it, tells us that if we have a wedge on one line, and if on another line we have the negation of the first of what comes before the wedge, then we can get what comes after the wedge. So here we have a wedge, and what we ended up with was what came after the wedge. So what did we need on this line? Well, if we follow disjunctive syllogism, which we should here, then what we need is not W. And that would allow us to get H. So if we know W or H is the case, and we know that W is not the case, then we know that H must be the case. So how did we do that? We did 1, 2, disjunctive syllogism. Sorry for the weird formatting. All right. So that's how you do it. You'll see there'll be a blank in your textbook, in this one for line 2, and a blank in your textbook down here for what rule we did. Let's do a few more before I turn you loose on some more practice problems. So here we're given a horseshoe, S horseshoe R, and what we ended up with was the consequent. So now we need to ask ourselves, what rule, if given a horseshoe, allows us to get know that the consequent is true? And what would we need on line 2 to get that consequent? Well, we look at our rules, and what we'd end up seeing is that MP is the rule that we're looking for. So MP tells us if we're given a horseshoe, and if on another line we're given what comes before the horseshoe, then we can get what comes after the horseshoe. So here we have a horseshoe. Here we have what comes after the horseshoe. So what did we need to get there? What we needed to get there was what comes before the horseshoe. So we needed an S on line 2. What rule did we use? 1, 2, and sorry, my P button doesn't work. And my tilde button doesn't work. All right, so that's how we do that one. Now let's try this one down here. So if we know if A, then L, and if what we're trying to get is tilde A, then what did we need on line 2 to get there? So what rule allows us, given a horseshoe as the main operator, to derive the negation of the antecedent? And the rule that we would come to is MT. MT tells us if we have a horseshoe as the main operator, and if on another line we have the negation of the consequent, we can get the negation of the antecedent. So here we have a horseshoe, A horseshoe L, and what we're trying to get is not A. So what we needed, if we follow the pattern of MT on the second line, we needed tilde L. And what did we use? 1, 2, MT. All right, so just a few more then. So here we're given a horseshoe, and what we end up with is a horseshoe. And it's asking us again, what did we need on line 2 to use together with line 1 to get this horseshoe on line 3? Now let's take a look at our rules here down in the bottom right corner and ask ourselves which rule starts with a horseshoe and also ends with a horseshoe. And we see that hypothetical syllogism is the one that does that. Here we have a horseshoe and another horseshoe, and we can get a horseshoe. So we'll need another horseshoe in our premise here to get to the horseshoe in our conclusion. So we'll definitely be using hypothetical syllogism. Now, let's take a look at what we have here. What we're trying to get is G horseshoe X. And what we have is B horseshoe X. So something to note in HS, let's study this a little bit. When you have P horseshoe Q and when you have Q horseshoe R, what HS lets us do is drop the thing that's the same and carry down the things that are different, the P and the R. So we're dropping the Q's, the similar things, and we're leaving the things and carrying straight down the P to the P down here and the Q or sorry, the R to the R down here, dropping the Q. All right, so what do we need here? We kept the X here. And we also need a G that we need to carry straight down. So what we need, we don't have a G up here. So what we need is a G here so that we can carry that straight down. And now on this line, we also need something that we can drop, because note in the HS, there's the Q that you drop on both lines, right? So what other letter do we have? Well, we carried this X straight down. We carried this G straight down. So what we're going to need on the other side of the horseshoe, whoops, is this B. So if we have that B, now this is using 1, 2, HS. One, two, just, ugh. There's no way I can do this. All right, imagine I wrote 1, 2, HS after that. So how did we do this? We saw that we had if B then X, and what we were trying to get was if G then X. So we're going to need a G somewhere. So we needed a G, and we needed a part that we could cancel out. So we didn't have the B down here, so we know that B is going to be the thing that is the same. So we had the B as the antecedent here, so we need the B as the consequent, and then we're just going to carry down the G, and we're going to carry down the X, and that's 1, 2, HS. All right, now it gets a little tougher. Here on line 1, we have a horseshoe, if L then S, and on line 2, we have if S then F. And what we're trying to get is not L. So we're trying to get tilde L. So what did we need on line 3 to use with either line 1 or line 2 to get line 4? So what we have is tilde L. So let's look for where we might find tilde L. Is line 2 going to be helpful for getting tilde L? No, there's no L there, right? So line 2 is off our list. So let's look at line 1. Line 1, we have L horseshoe S. Now, L was exactly what we're looking for, except we're looking for the negation of that. So we need to figure out a rule that if given a horseshoe, we can get the negation of the antecedent, right? Because the antecedent here is L. And if we look at our rules, we see MT will allow us, if given a horseshoe, to end up with the negation of the antecedent. So what did we need to get there? We needed the negation of the consequent. So what did we need on line 3? The negation of this, the negation of S. And that is just tilde S. And how did we get that? We did 1, 3, MT. We had a horseshoe, we had the negation of the consequent, oops, the negation of the consequent, so we could get the negation of the antecedent, tilde L. All right, one more before you get to your homework. So here we have either R or Q. If I, then R. We don't know what we had on line 3, but what we ended up getting was I horseshoe Q. So now we need to ask, what did we need on line 3 to get I horseshoe Q? Well, we don't have any rule that allows us to use a wedge main operator and get a horseshoe main operator. None of our rules do that. So line 1 is going to be out. Line 2 looks a little more promising. Here we have a horseshoe as the main operator. Here we also have a horseshoe as the main operator. So how can we get there? Well, hypothetical syllogism is the rule that lets us go from one horseshoe, and we need another horseshoe to finally get a horseshoe. So here we have I horseshoe R, and what we're ending up with is I horseshoe Q. So what do we need on this third line to get there? Well, we're going to carry down this this I to right here. And we need to carry down a Q from somewhere, but we don't have a Q here. So and remember, line 1 is useless to us. So we're going to need, after a horseshoe, a Q. So now what do we need before? So then we can carry down the I, we can carry down the Q, and something needs to be crossed out. And the only thing that remains is the R. So we'll need the R to be the same when it's the consequent. We'll need it to also be the antecedent of another horseshoe here. So then we can cross out, like cross cancel the R's, and we'll be left with I horseshoe Q, and we have that right down here. So that will be 2, 3, HS. And that's how we got there. All right. So these are the sorts of problems you'll find in 7.1 Roman numeral 2. So if you made it this far, pause the video and do all 20 problems in 7.1 Roman numeral 2 and do those right now. All right. Hopefully those aren't too bad. Hopefully you're following along, because finally we're going to get to what we're really building up to in this chapter, and those are the proofs. So the proofs are set out like this. We're given some information. So here we're given A horseshoe tilde B. We're also given C horseshoe B. And finally we're given A. And the game is to try to build a bridge from that information, those 3 given premises, to this conclusion, tilde C. And the steps that we're going to use are just these 4. We're going to use these rules and the information along with the information given. So we're going to apply these rules to the information given to get to this conclusion, tilde C, the thing after the slash. So how are we going to get there? The first thing I'd recommend you do is look for the conclusion somewhere in the premises. So here we have tilde C. Where do we see C or tilde C? We see it here on line 2. On line 2, it's the antecedent of a conditional statement of a horseshoe. So what rule do we have that will let us get the negation of an antecedent? The rule we have is MT. MT tells us if we have a horseshoe and we have the negation of the consequent, then we can get the negation of the antecedent. So here we have C horseshoe B. What we're trying to get to is tilde C. So what will we need? We'll need the negation of the consequent. So if we have tilde B somewhere, we can get tilde C. Where do we have tilde B? The negation of the consequent. We have it on line 1. But how can we get that by itself? How can we know that tilde B is the case? Well, we can get that if we could use MP to get the consequent, because MP allows us to, if we have a horseshoe, to get the consequent, as long as we have the antecedent somewhere. And we actually do. We have the antecedent to A horseshoe tilde B right here, A. So we're given that. So we can start with 1 and 3. Now, if that working backwards didn't make sense, here's another method you can do. Look at what we got and just do whatever you can with lines that go together, and then try to work it out from there. So here we're given a horseshoe as the main operator. On line 2, we're given the horseshoe as a main operator. So we might think, oh, maybe we can use hypothetical syllogism. But to use hypothetical syllogism, we need two parts to be the same. And in these first two lines, none of the two parts are the same. Here we have A, we have tilde B, we have C, and we have B. Nothing, we can't cancel out anything. So 1 and 2 aren't going to work together. So let's look at line 1 and line 3. Those two lines look like they could work together. Because here we're given if A, then not B, and here we're given A. So what can we derive from that? Using MP, we can derive what comes after the horseshoe. So we can derive tilde B. And how did we get there? We did 1, 3, M, P. All right, so now we have more information. Now we know that tilde B is the case. So then the way you proceed is with this new line. It's like you're an investigator in the case and you're given a new clue. You want to see how that new clue fits with the rest of the evidence, right? And what you can learn from that new clue. So now that we know tilde B, we want to ask ourselves, is there any line that we can use with this tilde B to get a new piece of information? Can we use line 1? No. We had tilde B up here as the consequent, but it's not the negation of the consequent, it just is the consequent. We don't have any rule that allows us to use the consequent to derive the antecedent. That's a fallacy. How about line 2? 2, we have C horseshoe B, and here we have not B, so that's actually the negation of the consequence. And if we look down here at MT, we'll see that if we have a horseshoe as a main operator, like we do on line 2, and if we have the negation of the consequent, like we do on line 4, then what MT tells us is we can get the negation of the antecedent. So here we have a horseshoe and we have the negation of the consequent, so we can get the negation of the antecedent, so we can get tilde C. So 5. And how did we get that? We did lines 2 and 4. And the rule we used on 2 and 4 was MT. And now look what we've done. We got to a place where we were trying to get to. So we built a roadmap from the first 3 premises, from the premises that we were given to the conclusion in 2 steps. So once we get to the conclusion that we were trying to get to, we stop. That's the end of our proof. All right, so now let's try this again. And what you might want to do is as you see these, you might want to pause and try them yourself, each step, or you might want to, I might want to pause it right now and see how much of this you can do. Or if you're stuck, allow me to do a step, pause it, see if you can get the next step. So what we're trying to do here is, given the information in these 4 premises, we're trying to get this conclusion, again, using these as our steps. So we have if A, then B, and if not A, then C or D. We have not D and not C, and what we're trying to get is D. Let me double check that I got this one down right. Nope, I didn't. That's more like it. It would have been really weird if on line 3 we had not D and what we were trying to prove was D. So that's how I knew that I was in error. So given this information, can we get D? First, let's look where D is. D we find right here. Now D is, if we look at this part of a wedge. Do we have a rule that lets us get the second part of a wedge? Yes. Disjunctive syllogism lets us do that. What would we need? We would need not C to get there. We have not C here, but we can't go directly from this and this to a new line because this so far isn't the main operator. Right now, the horseshoe is the main operator. So we're going to need to break this out of here somehow. How would we do that? Well, if the main operator is a horseshoe and this is the consequent, then MP tells us if we have the main operator as a horseshoe and if we could somewhere have the antecedent, we could get the consequent on a line by itself. So what we need is not A. If we have not A, then we can get this whole thing by a line on a line by itself, and then we can use the not C to get D. So we're looking for now is not A. How are we going to get not A? Well, up here is an A. How are we going to get the negation of that when it's the antecedent of a horseshoe? Well, if we had the negation of the consequent, then MT tells us that we can get the negation of the antecedent. So we do have the negation of the consequent on line 3. We have not B, so we can get not A. So then we could do not A, and we could get this on a line by itself. And then once we have that on a line by itself, we can use the negation of the first disjunct to get the second disjunct on a line by itself. And if that didn't make any sense, the way you do this is you look for two lines that go together and you just start doing stuff. So let's do that method. Let's look at line 1 and line 2. Do they go together? Well, they're both horseshoes. The rule that we would use for horseshoes being the main operator is hypothetical syllogism, but we would need an antecedent and a consequent to be the same. Here we have A, B, tilde A, C, or D. None of that's the same, so we can't use HS. So let's look at line 1 and 3. Can we use a rule on line 1 and 3 to derive some more information? Here we have a horseshoe as the main operator, and we have the negation of the consequent. Those will go together. Let's look down at MT. If we have a horseshoe as a main operator and the negation of the consequent, we can get the negation of the antecedent. So horseshoe, the negation of the consequent, we can get on line 5 tilde A, because we had if A then B and not B, so we know not A. So how did we do that? We did 1, 3, MT. So now, like I urged you to do, if you have a new clue, a new piece of information, you want to see what that can fit with to get some more information. So now we have this tilde A. What line could that go with to use a rule on both those lines to get a new piece of information? How about line 1? Nope. Here we have A horseshoe B. We have no rule that would allow us to have the negation of the antecedent to get anything else. We have a rule that says if we have the antecedent, we can get the consequent, but nothing that tells us if we have the negation of the antecedent. In fact, MT tells us if we have the negation of the consequent, then we can get the negation of the antecedent. So nothing that tells us if we have not antecedent, then something about the consequent. So we can't use 1 and 5. How about 2 and 5? 2, we have if not A, then C or D. Well, on line 5, we have not A. And if we know if not A, then C or D, and we know not A, then we can know C or D. And how did we do that? We did line 2 and line 5. And the rule we used was MP. MP tells us if we have a horseshoe, and if we on another line have everything before a horseshoe, we can get everything that comes after the horseshoe. So here we have a horseshoe. Here we have everything that comes before the horseshoe, so we can get everything that comes after the horseshoe. So that was 2, 5, M, All right, so now the new line that we have is 6. So let's see if we can use line 6 with something. So what we have in line 6 is a wedge. So the only rule we're likely to use right now, the only rule that has wedges as the main operator, is disjunctive syllogism. So disjunctive syllogism tells us if somewhere we have the negation of the first disjunct, then we can get the second disjunct. So here we have C or D. So if we had tilde C, we could get D. Do we have tilde C anywhere? Yes, we do, in line 4. So if we know C or D is true, and if we know C is not true, then we know D has to be true. So D, and how did we do that? That was 4, 6. Disjunctive syllogism. And look what we have here. Here we have D, what we're trying to get, D. So we're done. And we did that in 3 steps. We have justifications for all of our steps that were not given to us. So we're done with that proof. All right. How many more examples do I have? I have 2 more examples. Here, we're given 4 premises, and what we're trying to get is F horseshoe I. So let's see how we can do that. And if you want, you can pause me right here, do it yourself, and check the way you did it with the way I did it. So what we're trying to get is F horseshoe I. Now that's a horseshoe as the answer. One thing we might do if we're given the horseshoe as an answer is look to a rule that has a horseshoe as the thing we get in the end. And if we look, we see hypothetical syllogism is the rule that we have where we get a horseshoe at the end. So what do we need to get there? We need 2 other horseshoes. So do we have 2 other horseshoes here? We do. Here we have F horseshoe G, and we also have G horseshoe I. Now, if those were on lines by themselves, we could cut out the middleman of G and get F horseshoe I, and that's exactly what we're trying to get. But we can't just separate this out and pretend that the if H isn't there, because it is there. So we're going to need to get this G horseshoe I on a line by itself. So how would we do that? Well, if we had H, we could do that. Now, where might we get H? Well, here's H up on line 2 as a second disjunct. So if we could get, if somehow we could get tilde F, then we could have the negation of that and get H by itself. Now, where would we get tilde F? Well, here's F. How would we get tilde F? Well, if we had not G, then we could use MT to get not F, and here's tilde G. So then we can get not F, so then we can get G. And once we have G, we can use it for if G then I. All right, so pretty complicated. Let's just see what we can do. So what 2 lines go together here? Looks like lines 3 and line 1, we can use MT on that. So here we have a horseshoe, here we have the negation of the consequent, so we can get the negation of the antecedent. So that was line 1 and 3, MT. And now that we have this new information, tilde F, we look for a line that might work with. Won't work with line 1, will work with line 2. Here we have F or H, and we know not F, so with disjunctive syllogism, we can know H has to be the case. So that was 2, 5, disjunctive syllogism. And now we have a new piece of information. We have H. So what can we use H to get? Nothing with line 1. Nothing with line 2. Nothing with line 3. Here, line 4. We can use H with line 4. So here we have the horseshoe being the main operator here, the main operator being right here, and we have everything to the left of the horseshoe on another line. So MP tells us we can get everything to the left of the line. So everything to the left of the line is G horseshoe. And how did we do that? We did 4 and 6 and P. All right, so now we have G horseshoe I, and now we want to look at what line we can use G horseshoe I with. Recall that what we're trying to get is F horseshoe I. So how can we get to F horseshoe I with G horseshoe I? Well, if we had an F horseshoe G, we could cancel out the G's and be left with F horseshoe I. So do we have F horseshoe G anywhere? We do, on line 1. Now, the other way you could do the problem is just try to think, what does this go with? The only line that this works with that we have is F horseshoe G. Nothing else will work with line 7 to give us anything. So we have F horseshoe G on line 1, G horseshoe I on line 7, so we can cancel out the G as the consequent there, the G as the antecedent here, and be left with F horseshoe I. So there we have 1 and 7. Whoops. What do we get first? We get F horseshoe I. How do we do that? We did 1 and 7 HS. And we got the answer that we were looking for. We stop. We're done. We derived that proof in 4 steps using the rules of implication. All right, so one more, and I'm going to go through this one a little bit faster before we get to the quiz questions. All right. So here we're given 4 lines. We're trying to get to C horseshoe G. Where do we see G? G is here. C is here. C is the antecedent. G is the consequent. And look here, we have D as the consequent, D as the antecedent. So if we can get this on a line by itself, then we can do hypothetical syllogism. With this, cancel out the D's and get C horseshoe G. So we're going to need to break this line down. This big, long monster. And a lot of times in these proofs, when you see a big monster line, you're going to need to strip that for parts to use to get the answer. So here I'm having a period stand in for a dot. When you're doing your homework, I urge you do this homework on a Word document so you're used to it for the test if you haven't been doing it so far. If you have been doing pen and paper so far, then just switch over to doing it on the computer now. It'll help you for the test when you have to do proofs. All right. So often you have to break a line down to strip for parts to get to where you're trying to go. So you'll need to use the information on the rest of the lines. Man, I'm bad at copying these lines. All right. All right, so let's just jump into this. So here we have tilde A dot B, and here the main operator is a wedge. So disjunctive syllogism tells us if we have the negation of tilde A dot B, then we can get what comes after it. Here we have tilde A dot B, that's the negation of A dot B. So on line 5, we can get the remainder of what's there. So we'll get tilde open parenthesis E dot F close parenthesis horseshoe C horseshoe D close parenthesis. We can lose the brackets now because they're not doing any work. So if we still had the brackets, they would be outside here, and they wouldn't be separating this from anything, so we can drop the bracket. So how did we get this? We got this by doing 1, 2, disjunctive syllogism. All right, so now that we have this new information, what can we use with that? Well, here we have a horseshoe as the main operator, and the antecedent is not e.f. Here we have not e.f. So we can use that with modus ponens to get the consequent. So we can get C horseshoe D. How do we do that? We did 3 and 5 MP. 3, 5, M. And now that we have this, C horseshoe D, what can we do with C horseshoe D? What we're trying to get to is C horseshoe G. So what we need is a D horseshoe G, and we can get there, and we have it on line 4. So what can we use with line 6? C, if C then D, and if D then G, we can put those together to get if C then G. And how did we do that? We did 6 and 4 hypothetical syllogism. So 4, 6, HS. And we got the answer that we were looking for. So now we can stop. So what was our strategy? We wanted C horseshoe G. Where do we find the C? In the middle of this big messy line, so we know we need to break that down. We see the G here, so we know if we can get C horseshoe D on a line by itself and D horseshoe G, so here was C horseshoe D, D horseshoe G, then we can get C horseshoe G via hypothetical syllogism. And how would we get C horseshoe D on a line by itself? Well, we need tilde E dot F. Here we have that. So with that, we can do MP to get MP to get C horseshoe D, and then to get this on a line by itself, we had the negation of the first part to get that on a line by itself. So working backwards, it makes sense. So we did this in 3 lines. All right. So now we're going to have 2 quiz questions, and the way the quiz questions will work for the post-lecture quizzes, I'll give them in the lecture. You'll have to write down the number of the question and your answer, because when you open the quiz in Canvas, it'll just say what's the answer from number 1, A, B, or C. So take notes. Quiz question number 1. If we use hypothetical syllogism HS to derive a third line from the first 2, what do we end up with? So the first lines, F horseshoe Y. Second line, J horseshoe F. And what we're trying to see is what do we get on line 3 if we use 1, 2 hypothetical syllogism. Recall that we cancel things out and we carry the rest down. So do we get F horseshoe F, A? Or B, do we get J horseshoe Y? Or C, do we get F horseshoe J? If we use hypothetical syllogism on these 2 lines, what do we get? And you can pause it if you need to. All right, so the final quiz question number 2. What rule did we use on the first 2 lines to get the third? So our first 2 lines were neither A nor B. If neither A nor B, then not Z. And not Z. So what rule did we use on those 2 to end up with it's not the case that neither A nor B? So what rule allows us, given the negation of the consequent, to get the negation of the antecedent? Did we use hypothetical syllogism? Did we use hypothetical syllogism to get there? Disjunctive syllogism to get there, B, or modus tollens, C, to get there. Write that down, and that's the end of our very long lecture for this section. Hopefully it makes sense. I'll be posting a video with some of the more difficult homework problems from this chapter, but if you have questions, send me an email and I'll try to set you straight. Thanks for paying attention. Again, hope all is well for you. Hope you're being safe, and I'll see you next time.